Hello everyone, welcome to the channel Data Science Studio, and today we are going to start with day 2 of statistics for data science. And today we'll be discussing some of the important concepts of sampling and the different sources of data. So let's get started. So when we are talking about statistics, the first thing which comes is what are the different sources of data. So the different sources of data are primary and secondary. So when we talk about primary source of data, it is collected first hand and from a survey or observational study. So primary data is the information which is collected for the first time. It is collected for the first time from a survey or interviews or observational study. And it costs more. The cost of collection of primary data is more because you have to go to the source and collect your data, and then it requires more time to collect the data. Now there are various ways in which you can collect the primary data, and these are like you can go and have your surveys. So for example, if a company wants to do customer survey for a brand, they can plan their survey and they can get their feedback of the customers. And then we have experimental data. And this experiment data, the researcher conducts an experiment controlling the independent variable, and this is basically used in your field study or laboratory. And then third one, we have observational data. So in case of observational data, it is basically used in medical situations where the researcher simply observes the effect of the medicine on the patient and records the information about the respondent. So these are the different ways in which primary data is captured, and there is another source of data which is called as secondary data. So secondary data is collected by someone else. It is collected and processed by some other agency, but the researcher uses it for his study. So we use it, but it is being processed by someone else. And secondary data comes from two main sources. One is your published and another one is your unpublished. So when we talk about published sources, so we have like government publication like RBI bulletin, where they share information about the financial topics, and we have magazines and newspapers and journals. In international publication, we have something called as WHO or UNO. They have their own publications, and then where there are various research studies by the institutes like ICMR, Indian Council of Medical Research. So secondary data, again, it is collected and processed by someone else. So these are some other agencies, but if we want to use it, we can go ahead and use it. The advantages of secondary data is it costs less because it is readily available, and it requires less time to procure. So these are the differences about the primary data and the secondary data. Now next thing which we have already discussed in a previous session is there are two types of data. One is qualitative data and another one is quantitative data. So qualitative data, when we talk about the categorical variable like gender or blood group, which has certain categories, that is categorical data. And when we are talking about quantitative data, it is basically can be expressed in numerical scale. And for example, height, weight, these can be expressed in a numerical scale, but your gender or blood group cannot be expressed in a numerical scale. Next topic which we are going to talk about, which is very important from the which forms the base of whole statistics, is one is population and another is sample. So what is population? So population refers to So population refers to all units or objects within the purview of an experiment. So if you are doing an experiment, for example, if you are doing a employee survey, so if you are doing a employee survey of a MNC, then all the offices of the MNC and all the employees are your population. And there are two kinds of population, one is finite and one is infinite. Infinite is something which is very large, it is difficult to capture each and every item of the population. Finite is something, this same example, if you are doing an employee survey of a MNC company, then all the employees of the MNC offices will be your population, that is finite. Finite means which is countable, which is we can count. Infinite is it is difficult to count, uncountable. So most of the time we work with either finite population or infinite population. For example, there is another example of finite population, which is your census of India. So census of India is actually carried every 10 years, and it is a example of finite population where the population of the whole country will be determined. Now at times it is not possible to collect each and every item of the population, so we go with a sample. So what is a sample? So sample is a subset of the population to study the characteristics of the population. So and when we are talking about sample, there are certain term which is called as sampling. So sampling is actually a technique adopted to select a sample. So if you have to select a sample, you have to follow some techniques, and that technique is called as sampling. And the sampling method used for selecting a sample is important in determining how close the sample resembles to the population. So your sample actually represents your population, so it is very important that the sample should be unbiased. Now we will talk about advantages of sampling. So the advantages is cost, and time and accuracy. So cost and time goes down when you are collecting the data about your sample, because in population, to collect all the items about the population, it will take a lot of time, and hence collecting the data about the sample takes less time. Now there are two ways in which you can collect the sample information. One is called as probability sampling, and that is called as non-probability sampling. So probability sampling is also called as random sampling, and in random sampling all items have a positive probability of getting selected. So for example, if we have 1000 elements items in the population, then if we are taking a sample of 10 elements, then all elements have a positive probability of getting selected over here. And probability sampling, most of the time we go with probability sampling in our data science or statistics, because we want an unbiased opinion of the data. And they are classified into three types. One is simple random sampling, one is stratified sampling, and then we have systematic sampling. So we'll talk about what is simple random sampling. So in simple random sampling, each item in the sample have an equal probability. This point is very important. Each item in the sample have equal probability of being included in the sample. And there are two types. One is with replacement, another one is without replacement. So we'll see an example. So let's say that I have a deck of cards. Let's say I have 100 cards, and I want to pull 10 cards out of it. at random, which is random sampling. Now let's say I have pulled a card with number 3. So the probability of, first of all, it is a probability sampling because the probability of getting each card selected is 1 by 100, which is 0.01. So this is the probability which is same for all the cards, and this is a positive probability. And one more point, probability always lies between 0 and 1. And I have pulled a card with number 3. So my probability of getting a card 3 is again 1 by 100. Now if I am this 100, what is this 100? This 100 is total number of items. It is also called as sample space. Now if I am not putting this card back, so my sample space will reduce to 99. So the next card which I am pulling, it will be 1 by 99 is the probability. The probability changes. So if I am not pulling the card, if I am not putting the card back into the deck, it is called as simple random sampling without replacement. And if I am putting the card back, it is called as simple random sampling with replacement. So when we are doing with replacement, the chances of getting these 3 selected again is again the same. You might get 3 twice or thrice, doesn't matter, it is a random selection. But if you are doing sample random sampling without replacement, then your chances, your sample space will keep on changing, and your probability also will keep on changing for each the elements after the element is pulled up. So we will discussing the probability concept more detail in our tomorrow session. But the idea is simple random sampling is of 2 types. One is without replacement and one is with replacement. And then we have something called as stratified sampling. So in stratified sampling, the heterogeneous population of size n units. So your heterogeneous population is subdivided into homogeneous population, and which we also call it as strata. So your heterogeneous population is divided into homogeneous population, which is strata. So now let's say that I want to take the employee feedback of an MNC in different offices. So let's say I have office 1, and then I have office 2, and then I have office 3, and then I have office 4. So in office 1 I have 1500 employees, in office 2 I have 1000 employees, in office 3 I have 2000 employees, and in office 4 I have 2500. So if I consider the whole population, it is 7000. So this 7000 represents a heterogeneous population, but the different offices represent a homogeneous population, and this is also called as strata. And let's say that I have to select a random sample of 250 employees for survey from these offices. So how we can get from office 1, it will be 1500 divided by 7000 into 250, which is 54, and then we have 1000 divided by 7000 into 250, which is 36, and then we will have 2000 divided by 7000 into 250, which is 71, and then we have lastly is 2500 divided by 7000 into 250 is equal to 89. So total will be 250. So in this manner, this is a stratified sampling where you get a representation of each and every office in terms of the employees. This is called as stratified sampling. And then we have lastly, which is called as a systematic sampling. So in systematic sampling, the population is actually ordered in a descending order, and let's say that I have 200, I have numbers from 1, 2, 3, 4, 5, 6, 200, and let's say that I have to select a systematic sampling of 20 samples, 20 units you can say. So let's say I select a random sample as 5. So 5 will be my first sample, and since I have to select 20, then how many numbers I have to select? 200 by 20 is equal to 10. So the next number which will be is 15, then 25, then 35, then 45, and so on and so forth till 10 numbers. So in this case, I am trying to get the 20 numbers with a gap of 10. So this is called as systematic sampling. So here you have selected a random number, and then based on the total number of samples you get, you make a difference of it and you just pass on this. This is the first interval is actually 5, and then so on and so forth. The intervals will be added accordingly. And then this non-probability sampling is just for your reference. We normally don't use in data science. They are basically used in marketing research, which is convenience sampling, judgment sampling, quota sampling, and snowball sampling. So in case of convenience sampling, the samples are drawn at the convenience of the researcher. So for example, if you want to take the survey of a Indigo flight about the customers, then you have to take their permission and you have to take the survey at their convenience. So this is convenience sampling. And then we have something called as snowball sampling. So in this type, initial group of respondents are selected. So it is something like this. So in initial group of respondents are selected, let's say A and B are selected, and then A and B will be asked to select the next set of respondents. So then A, B will be asked to select the next set of respondents like this. This is called as snowball sampling. And then lastly we have judgmental sampling. So in judgmental sampling, the researcher believes that in his opinion some objects are best representation of the population. For example, if a college is going into a quiz competition, then the college will select the candidates based on the performance in the internal quiz. That is called as judgmental sampling. Now there is another concept which is important to understand, which is called as sampling error. So the purpose of sample is to study the population characteristics, and the sample size is always less than or equal to population. Now whenever we are calculating a sample, creating a sample, there are some statistical measurements like mean, median, which represent the central value of the data. Now let's say that my let's say that my sample mean is x bar and my population mean is mu. So population mean is represented by mu and sample mean is represented by x bar, and then the sampling error is calculated as x bar minus mu. This is the sampling error, and it can be positive, it can be negative, or it can be 0. So the sampling error actually should be very less, then only we can say that my population is actually my sample is actually the truly representation of the population. And the last topic for today's session is we'll be talking about some of the diagrams and graphs which we use to represent the qualitative data and the quantitative data. So when we talk about qualitative data, which is basically categorical data, we talk about bar chart, Pareto chart, and pie chart. And in quantitative data, we will be discussing the histogram. There are some others as well, like frequency polygon and frequency curve as well. So let's talk about bar chart. So in bar chart, let's say that I have to identify the sales of cars of brand A over 5 years period. So I'll plot something like this. So this x axis will be year and y axis will be sales. So this is 1 year, this is 2 year, second year, this is third year, this is fourth year, and this is fifth year. So this is 1, 2, 3, 4, 5. So the year is actually your category, and total number of sales is 10K, this is 20K, this is 30K, this is 40K. So your year is actually a category in which you are clubbing your sales. So this is a bar chart, and there are various representations of bar chart. You can have, there is something called as stacked bar chart. So if you have multiple categories, you can show it as a stack. So when we are starting in Python, we will see that how we can work with stack bar chart. Next is called as Pareto diagram. So in case of Pareto diagram, it is similar to bar chart, but it is organized in a descending order like this. The sales will be organized in a descending order, but it is similar to bar chart. This is again year, and this is again sales, and this is called as Pareto chart. But in our data science and data analytics, we normally go with bar chart only. And another chart which is we normally use is called as pie chart. So the pie diagram is actually a circular diagram, and in this circle actually represents a 360 degree, and it is divided into different sectors like this. It can be divided in different sectors like this. Now let's say that we have a monthly salary of 15,000, out of which base is 10,000, and your LTA is leave travel allowance is 2,000. This is just a rough estimate, and your HRA is 3,000. Now if I have to represent this data into bar chart, how I will represent? So first I have to calculate something called as angle. So I have to divide this 360 degree based on the magnitude of this data. So my total is 15K. So my base angle will be 10,000 divided by 15,000 into 360, which is equal to 240. And then my LTA will be 2000 divided by 15,000 into 360, which will be 48. And then I have HRA will be 3000 divided by 15,000 into 360 equal to 72. Now if I have to plot the bar chart for this, so this will be close to 240 degrees, and then I have 72 degrees. This is my HRA, this will be my LTA, and this will be my base. So this is called as pie chart. So pie chart also we used in many occasions. The last one is for the quantitative data, which is histogram. So histogram is used to represent, used to show the how your data is distributed. So there is a concept called as normal distribution. So whether your data is normally distributed or whether your data is skewed, so this is shown by the histogram. So histogram is a very important chart which is basically used to show that how your data is distributed. So let's say that I have 200 students in the class and I want to categorize them based on marks. So let's say for 60 to 70 I have 60 students, for 70 to 80 I have 80 students, and from 80 to 81, sorry, 60, this is 61, 81 to 90 I have 30 students, and then 91 to 100 I have again 30 students. Now if I have to plot a histogram, then histogram is a attached bar chart. Attached bar chart where all bars are attached to form a distribution, and it displays the distribution of frequency distribution. So this is frequency distribution. Frequency distribution means that between 60 to 70 there are 60 numbers, between 71 to 80 there are 80 numbers. So this is my y axis will be number of students, and my x axis will be marks. So this is, first is 60 to 70 like this, and then 70 to 80 like this, and then 81 to 90 like this, and then 91 to 100 like this. So this is 60, 70, 80, 90 and 100, and this is your marks. This is 60, 80, and then you have over here 30. This is rough scale. So here you can see the distribution of the data is like this. So your data should always be normally distributed when we are talking about quantitative data. So histogram is a very important chart graph which we actually do in our projects. So today we have seen very important topics like sources of data and random sampling, how the data samples are collected, and what all the different diagrams and graphs are used for qualitative and quantitative data. In our next lecture, we will be talking about predominantly about our quantitative data, the measures of central tendency, measure of dispersion and measure of skewness. So that's it for today. Please subscribe, like and comment your channel, and stay tuned and stay connected. Thank you.